Hey guys, welcome to 11.4a Graphing Sine. So graphing sine and cosine is what we're going to be working on for these next few lessons. They're very similar in the process, but you have to understand a little bit more about how sine and cosine relate to x and y on what is called the unit circle. So if we look down here, this is basically a perfect circle on a coordinate grid. And this is what we've been working with already when we're finding like reference angles, when we're finding the different values in the different quadrants. So just a couple key points that I want to mark here. Remember that the starting point is 0 degrees, and that's also the same as 0 in radians. It's also 360 degrees, or 2 pi, once we complete the full circle. So those are two things we want to mark. Up at the top here, this is 90 degrees, or in radians, it's pi over 2. This one here on the left, this is 180 degrees, halfway around, or pi in radians. And then the last one, we have 270 in degrees, or 3 pi over 2 in radians. And then we would, circle back around and start back at 2 pi. Now, we also talked about some coordinates here. Every single one of these dots here is a different coordinate pair, and it's formed by thinking of them as like a right triangle that we would draw, and these would have different values. Okay, so the important coordinates though that we want to mark are these four here, and we've already talked about these. These are the quadrantal coordinates. So this one is 1, 0. This one is 0, 1. This one's negative 1, 0. And this one is 0, negative 1. Those are going to be important when we're graphing sine. Now remember, when we're talking about these, they're an x and y pair that we think of as cosine for the x value, sine for the y value. So since we're graphing sine today, our focus is going to be on sine. So all of the y values from these coordinate pairs are going to be really important. All right, so let's actually graph the original sine function. And what I want you to think of sine as is y equals a sine of b times x. So a is going to be what is called the amplitude. It's how high or low our graph is going to shift. And then the b value is going to help determine what is called the period. And once you see it, I can kind of explain it a little bit better. So if we were to draw in the unit circle again, and we were to mark those points, those 4 points. We'll do this here, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Again, we're thinking of the y values here, but we also want to think about, well, what are the radian measurements? Because we're going to be graphing this in terms of radians. So it goes from 0 to pi over 2, and then to pi, to 3 pi over 2, all the way back to 2 pi. So those are going to be the x values in this case. So imagine that if you were to type in the sine of 0, what would you get out of your calculator? The calculator is going to give you 0 because that's the y value. The next important radian measurement that we would type in is pi over 2. So pi over 2, if we type that into our calculator, the sine value is 1. And then you get the idea. So it's going to be pi, 3 pi over 2, and then we rotate all the way back around to 2 pi. So we start here, and basically we're just completing the circle. Now, the y values for each of these changes. We start at 0, this one right here, and then we got 1, and then the next one is back to 0, and then we're back to, or down to negative 1, and then back up to 0 again for the last number. So for the coordinates, we're thinking of the y value. And then a times y, a in this case is what's ever in front of sine itself. We just assume it's 1. So we're going to have the exact same values. Now when we graph this, mark here, this is 1, this is negative 1, and we're starting with this coordinate pair right here, 0, 0. So we can cross off this middle column now that we're done with it. So 0, 0, which is right there. And then we need to make some increments for ourselves here. So the first one, this is 0, and then it's pi over 2, pi, 3 pi over 2, and then 2 pi. So we start at 0, 0, and then the next pair is pi over 2, 1, and then it's back to 0, so that's our next one, and then it's 3 pi over 2, negative 1, and then 2 pi. So I'm just going to connect these here, kind of curve them as I go, and this would actually continue on. This is a, kind of an infinite function that's going to continue. But that is the general sine graph. Notice it has a high point and a low point, and that pattern would continue forever and ever and ever, where you'd have highs and lows, and then it would also have this like inner part here where it's crossing the x-axis. So some things to note about this graph: functions of y equals sine of x and y equals cosine of x. The domain is all real numbers, so we can plug in anything. The range goes from -1 to +1, and that's dependent upon the a value. Since we have an a value of 1, it doesn't change that much. It's periodic, meaning that it's repeating, and that continues infinitely. A cycle is the shortest repeating pattern, and a period is the horizontal length of each cycle. So in this case, it's 2 pi is the period, because that's how long it took us to get from this point all the way to here, and then we would see the cycle repeat. The maximum value is 1 and -1, as that's the highs and lows. And then the amplitude is the measure of change over a single period, so the vertical height. All right, now, again, just in general, the amplitude is the absolute value of a, and the period, this part is important, 2 pi divided by the absolute value of b. So whatever the b value is, the value next to x, that's going to determine the period. Sometimes it makes it larger, sometimes it makes it smaller. But either way, we're going to divide this up into equal parts. So let's go ahead and try this next one here. With this problem, we are graphing y equals sine of 1/2 x. So the first thing we want to do is list the amplitude. So the amplitude is the number in front of sine. In this case, it would just be 1. And then the period, what we do to find the period, because it changes depending on the b value, so whatever in front of the x, it's 2 pi divided by 1/2. So be careful here since we're dividing by a fraction. So that's the same thing as 2 pi times the reciprocal of 1/2, which is just 2. So the period is 4 pi, which is a larger period than what we did for the original function. So what that means is we need to take 4 pi and split that up into like 4 equal pieces, 4 equal increments. If you divide that by 4, you get pi. So that's what we're counting by in the x column. So it's 0, pi, 2 pi, 3 pi, and then if you do it correctly, you should end with the complete period from 0 to 4 pi. Now the y values are actually going to be the exact same as they were before in the graph. Since our amplitude is 1, it's going to be the same values when we think about the unit circle. So it's this point, this point, this point, this point. This is 1, 0, 0, 1, -1, 0, and 0, -1. So the y values starting over here, it's 0, +1, back to 0, -1, back to 0 once we get there. Okay, and since the a value is just 1, it's going to be the exact same, so we don't even really need to fill out that last column. So this time we're starting at 0, 0, and then we are counting by pi this time rather than by pi over 2 in the last one. So this one, it's 0, pi, 2 pi, 3 pi, 4 pi. And then our highest and lowest points in the y column are 1 and -1. So we go 0, 0, and then it's pi once. We go over pi, up 1, and then 2 pi we get down to 0, 3 pi goes down to -1, and then 4 pi we're back to 0. And then we just show that this would continue. So we put arrows on both ends, and there we go. We have it graphed. Again, this is just one of those graphing concepts that you have to practice a few times. You really need to understand how to break up the period. That's usually the toughest part. But the graph itself is basically going to look identical every single time. Okay, so this one, there's a little bit more going on here. Graph of y equals 2 sine of x divided by 4. So the amplitude this time is different. It's going to be 2 because we have a 2 here, meaning we're going a little bit higher than we were before. And then the period this time, so x divided by 4 is the same thing as 1/4 x. So this time it's going to be 2 pi divided by 1/4, which is the same as 2 pi times 4, which would be 8 pi. So this is, again, a much larger period than it was before. So we need to break this up into 4 equal parts. So you just divide it by 4. And this one that you start with is always just going to be 0. That's pretty consistent. So 8 pi divided by 4 would be 2 pi. So that's what we're counting by each time. So now this one's going to be 2 pi, 4 pi, 6 pi. And again, we did it correctly, so we should end at 8 pi. The y values are going to be the same as what they were before. If you want to just look up here, it's going to be those same coordinates. Hopefully you're kind of seeing the pattern. So it's 0, 1, 0, -1, 0. Now we do want to use the third column since we have an amplitude of 2. So we need to take everything in the y column times 2. So it's going to be 0, 2, 0, -2, 0. We no longer want this third column. So now our coordinates are going to be 0, 0, and our new height is going to be 2, -2, like this. And then we want to count by 2 pi each time. It's 2 pi, 4 pi, 6 pi, 8 pi. So this is 0, and then we go up to 2, go back down to 0, down to -2, back to 0. And it's the exact same shape. It's just the numbers in between that are changing. Okay, so that's how you graph that. Now let's look at just a couple amplitude and period questions. These ones can be a little tricky when you're not actually just doing the graph. Y equals sine pi of x. So we think of this as y equals a sine b times x. Since the a value, there's nothing there, we assume it's just 1. And then the period is interesting because notice it's pi in front of x. So it would be 2 pi divided by pi. And in this case, the pi's just go away. So the period is just 2 this time. So that's also a little different. This next one here, 3 is in front of the sign, so the amplitude is 3. And the period, since we don't see a number there, we assume it's a 1. So it's 2 pi divided by 1, which is just 2 pi. So that's how you get the answers to those. Let's check out this last example here. Write an equation of the form y equals a times sine b of x with the given amplitude and period. So the amplitude is 2, and the period is pi. So the amplitude part's pretty easy. It's just going to be y equals 2 sine. There is going to be a number in front of x. We don't know what that number is yet because the period is 2 pi. But assuming that we knew what that number was, we'll call it b. We just need b to give us some number that when it divides into 2 pi, it just becomes pi. So what you would do for this one is just multiply both sides by b. So you'd get 2 pi because the b's would go away, equals b times pi, divide by pi, and you would see that b equals 2 because those would go away. So this is the equation. Y equals 2 sine of 2x. Do a couple more of these here. So the amplitude here, y equals 1/2 sine of 3 pi. So this one's a little bit trickier still. So we do 2 pi divided by b equals 3 pi. Again, you're going to multiply both sides by b. You get 2 pi equals 3 pi times b. So to get b by itself, divide by the number in front of it. Pi's are going to go away and we get a fraction of 2/3. So it's 2/3 x. Next one, y equals 1 in front of that, so we can just write sine, leave some space because we got to solve for this one. So pi over 2 is equal to 2 pi divided by b. Whenever you have one like this, it's a fraction equal to a fraction, you can actually just cross multiply this one. So you would get 4 pi equals b times pi, divide by pi. This one ends up being a little bit nicer. It's just b equals 4, so it would be 4x. And then the last one, y equals sine of 1/4. Oh, I messed up on that one. 1/4 is the amplitude, so that's got to go out front. 1/4 the sine of, and if it's 2 pi, then it's actually just x, because 2 pi is the original, so there's no number changing it. All right, and that is graphing sine.